Hi, everybody. Today is the last day of classes, the Friday, December 9th. So today is the last day you submit your homework, the practice exams, exam correction, and records. Okay? So, except the practice final exam. The practice final exam is due on the final exam dates. But everything else must submit by today's midnight. Because over the weekend, I will start to calculate your grades, including the extra credits. So if you have your notes, you want me to check your notes, please come to my office hours this afternoon from 3:30 to 5. My office is in the Snyder 159. Okay, so over the weekend, I will calculate your attendance bonus, the note-taking bonus, and add the evaluations, 0.2 or 0.3%. And then I will after I finish calculating your score, I will email you and have you to help me to check. Okay? I do apologize in advance if you miss some day, but if it's like a school sponsored event, so it should be excused absence. So if I didn't count that, please email me, okay, so that I can change your score. So if you go to Starfish, you know where the Starfish is? The blackboards. So you go to the blackboard. And then do you see here on the left lower corner? I mean, you click the Starfish, and then you can see your attendance. So yeah, I put the attendance over there. So you can see which date you missed the class. Okay. All right. And right, so our exam is on Wednesday. So after I email you the score, you can, if you have like, if you find some mistakes, please let me know before Wednesday. Because then after I get your final, I will grade it, and then I will post your grade on Thursday. So, and then at that point, there's nothing we can do to change your grade. Okay, so your performance decides what grade you earn. Okay, yes, so today, if you still miss some practice exams, exam correction and wrappers, please submit by midnight. Hi, Autumn. I have your exam, so you can do exam corrections and wrapper. Okay, so let's see. By the way, the review sessions on Wednesday. Yes, the review session on Wednesday. 3 students came. Okay, but the recordings. So you can go to TED Live, and then you click this 3 bar here. That's the menu. Then you can see the recordings. So the review session recording was 2 hours 12 minutes. Okay, so I really hope you can do well on the final exam. You promised me do the practice final exams, and for the problems you don't get 2 points. Please watch the recording. Okay, the session recording, and make sure you understand every step. Okay, everybody? Okay, so yes. Study really hard because you don't want to take this class again. So try your best. Okay, so review session recording is right here. Okay, so today we're gonna continue to talk about sections 8.8, vectors. And last time we said vectors. Okay, so let's say we're on the xy plane, so R2. Then our vector, we have 2 coordinates, the x coordinates and y coordinates. And given a point P and a point Q, to find the vector PQ, we use the terminal points subtract the initial points. And when we do this like vector subtractions, we calculate the entries respectively. So the first entry, okay, the first entry, the Q1, we subtract the first entry of the P, which is P1. And the second entry, we use Q2 minus the second entry of the P point, which is P2. So we do the entries respectively. Okay, everybody? So, and then the magnitude or length of the vector is the square root of each component square add them up. And if the magnitude of V is 1, we say V is a unit vector. And the magnitude is a number. See, the V is a 0, the magnitude of V is 0 if and only if V is the 0 vector. Oh, for the 0 vector, this is our notation. It's 0, and then you put arrow on top of it to denote this is the vector. So this is the vector 0, 0. Right, everybody? Okay, and then time we did example practice 1, right? Find the component form and the magnitude of the vectors that has initial points 4, -7, and terminal points -1 and 5. So the vector PQ is we use point P minus point Q, terminal points minus the initial points P. So therefore, -1, 5 minus 4, 7. So look at the first entry, -1 minus 4. Second entry, 5 minus -7. So -1 minus 4 is -5. 5 minus negative becomes plus. 7 is 12. So this is the vector PQ. And then when we compute the magnitude of PQ, it's the square root of each component square. Add them up. And don't forget the parentheses. That's why -1 square become 1. So this is -5 square is 25. And 12 square is 144. And then square root of 169 is 13. Do you still remember that? That is how we compute the vector and the magnitude. Okay, next, vector addition and scalar multiplication. So when we add two vectors, we add the entries respectively. So the first entry, u1 plus v1. Second entry, we add the u2 and v2. Is that okay, everybody? And then scalar multiple. So if we use a number to multiply a vector, well, we multiply this number to all the entries in that vector. It's like distribute, right? You multiply the k to all the entries of that vector. Okay, so next one, geometrically. To add vectors geometrically, you place them tip to tail. Okay, let's say here we have the u. Okay, let me see. So u is here. Let's say v is here. And how do we add vectors? Well, let's place the vectors tip to tail. So this is the vector u, and then let's move the v. So shift the v to here. So I place the tip. Okay, so this is the tip of v. We place it at the tail of the u. So this is the v. Then the sum u plus v is the vector formed by joining the initial points. Oops. Joining the initial points of what happened? Yes, it was erased. Yes, joining the initial point of u to the terminal points of v. So this is u plus v. And you can also see this is like a parallelogram formed by the vector u and v. And the u plus v is like the diagonal of this parallelogram. So that's why this technique is called the parallelogram law. Since the sum of the vectors is the of a parallelogram having adjacent sides u and v. Is that clear, everybody? So that is sum of two vectors. And how about the difference of two vectors? So we have u minus v. Place the vector u. Okay, so we have u. And let's say we have v. Well, you can think it this way. U minus v is the same as u plus negative v. Well, negative v is what? It's like the v but the opposite direction. Can you imagine, everybody? So this is like the v but the opposite direction. So this is negative v. And then we use u plus the negative v. So we move this negative v up there. Okay, so we move it up there. So this is negative v. Therefore, u plus negative v is here. Okay, so this is u minus v is right there. And then you also notice that, wow, this is the same as this. Right? Because vectors, I can move the vectors around. Right? This vector is the same as this vector. Okay, so therefore, this is u. Let me move the u closer to it. Okay, so this is u, and this is the v. For the u minus v, we are using the terminal points of v and then point to the terminal points of u. Okay, assuming the initial point are the same. So this is the vector sum and the vector difference. So far, so good, everybody? In the final exam, I'll just ask you to compute the vector, and then I won't ask you to draw them. So you won't need to worry about how to draw it. Okay, I'm just showing you what it looks like. Okay, practice. We have u and v. We want to find the following. So 2u. Okay, so 2u. 2 times u. U is negative 2, comma 5. Scalar multiple. So, which means we multiply each entry by that number 2. So you distribute 2 times negative 2, 2 times 5. What's 2 times negative 2? Negative 4. 2 times 5? 10. Yes. So that's part A. Part B. What's v minus 3u? Okay, v is 3 comma 4 minus 3 times u. U is negative 2 comma 5. So far, so good, everybody? And did I give you the attendance sheet to sign? Not yet. So I just turned off my alarm and keep talking. Okay. Let's see. All right. Thank you. Okay, so we keep going. All right. So now look at the first entry. The first entry we have 3 minus 3 times negative 2. So 3 minus 3 times negative 2. That's the first entry. Well, the second entry, you see, that's 4 minus 3 times 5. 4 minus 3 times 5. Is that okay, everybody? You do the first entry. Okay, calculate it, and look at the second entry and calculate it. All right. So therefore, negative 3 times negative 2 is 6. 3 plus 6 is 9. And 3 times 5 is 15. 4 minus 15, negative 11. Right, everybody? Okay. Good. That is part B. Let's keep going. Okay, so part C. We're doing U plus 2V, and we want to find the magnitude of that. Okay, so part C. So you can consider this is like 2 steps. Step 1, we want to find the vector. U is negative 2 comma 5. Plus U plus 2. So 2 times V. How about let's make the problem more challenging? How about let's do 5U minus 2V. Let's do 5U minus 2V. Okay, then we put a 5 there. So let's make the problem more challenging. Okay. Because in the final exam, you might have not just U, you may have something times U. Okay? So now, look at the first entry. First entry, you're using 5 times negative 2 plus 2 times 3. Can everybody see that? So 5 times negative 2 and then plus 2 times 3. That's the first entry. And then the second entry, we're using 5 times 5 and then plus 2 times 4. Right, everybody? Okay, good. Let's calculate and see what do we get. Okay, so 5 times negative 2 is negative 10 plus 6 is negative 4. 5 times 5, 25. 2 times 4, 8. 25 times 8, 33. Thank you. Okay, we're not done yet because we want to compute the magnitude of this vector. Well, that is the square root of each component square. Okay, so first component square plus the second component square. All right, 4 square is, thank you, 16, right? What's 33 square? Yeah, do it on your calculator. What do you get? 1089. Ooh, yes. So we add the 16. We get what? 1105. Yes. Okay, so you can leave your answer like that. Okay. So this is the vector and vector operation, and the magnitude of the vector. So any questions? Are we all good? Okay, so we keep going. Here are some properties of vectors additions and scalar multiplication. So the first one, U plus V is V plus U. So this means addition is commutative. So addition is commutative. So commutative means you switch the order, they're equal. And then second one, U plus V first and then add W, or you can do V plus W and then add the U. So this means addition is associative. Okay, associative. So that means you can do the first two operations, the U and plus V first, and then add the W, or you can do the last two operation first. So V plus W and then add the U. Okay, and the next one, u plus 0 is u. Yeah, 0 is a zero vector. And then the fourth one, u plus negative u is 0. So that's why we have an inverse. So the inverse is negative u. Okay, so negative u exists. For every vector, we have an inverse, which is negative u. So we add them together, we get 0 vector. And then the fifth one, multiplication of scalar is associative. Okay, so multiplication of scalar is associative. And then number 6. Ooh, number 6, you see? C plus D times U is C times U plus D times U. So this is the distributive property. And also, we can have C times U plus V is C times U plus C times V. Okay. And number 8, 1 times U is 1. 0 times U is a 0 vector. Well, here, make sure you can distinguish the vector versus number. Okay? Vector, you put an arrow on top of it. Number, you just put the number. Okay? So make sure you distinguish the vector and the number. And then number 9, C times U equals the absolute value of C times the magnitude of U. Okay, so you can pull the C outside. But when you pull the C outside, make sure you have the absolute value. Because the length is always greater or equal to 0. Okay, that's why the C could be positive, could be negative. So when you want to put it out, make sure you put the absolute value around it. Okay, and then unit vector, the norm is 1, right? So for any non-zero vector v, we can find a unit vector in the same direction as the v. So let's say this is the v, and we want to find a unit vector in the same direction. Let's call it u. And unit vector means the norm is 1. Well, how can we do that? We can use the magnitude of v. We can use v over the magnitude of v. Well, in this case, you can see what's the magnitude of u? Well, the magnitude of v over the magnitude of v, right? But because this is the same as 1 over the magnitude of v, and this is a number. See, this is a number. And it is greater than 0. That's why we can move it outside of the magnitude. Ooh. So once you move it outside, do you see what's left inside? It's just the v. Okay? Now you have the magnitude of v divided by the magnitude of v. They cancel. So you get 1. So to construct a unit vector in the same direction as v, you just use v over the magnitude of v. Is that clear, everybody? So vectors, 2 important things. One is the magnitude. The other one is the direction. Good. Let's keep going. Find a unit vector of v. So v is -2, 5. Okay. How do we find it? Use that formula. First, we compute the magnitude of v. Well, that is the square root of the sum of each component square. What's -2 squared? 4. 5 squared? 25. Do you see we get square root of 29? Okay, good. So our unit vector we can do v over the magnitude of v. V is -2, 5 over magnitude of v, which is square root of 29. Okay, so you can use a vector divided by a number. It's like you use each entry divided by this number. So therefore, you have -2 over square root of 29 and 5 over square root of 29. So this is what we get. By the way, to find a unit vector, this is a unit vector in the same directions as the v. And if you want to find the unit vector in the opposite direction as the v, okay, then this unit vector will be -v over magnitude of v. Okay? Because it's the opposite direction. Opposite direction, then you just put a minus sign in front of it. Is that clear, everybody? All right. So keep going. Next, horizontal and vertical components of a vector u with magnitude okay, let's say we're given, this should be double line, the magnitude of u can be calculated by, so ux, the x component, is the magnitude of u times cosine theta, and uy is the magnitude of u times sine theta. Okay. And so let me draw a picture here. So let's say this is the x-axis, this is the y-axis, and let's say the vector u looks like this. Okay, and we want to write down, okay, what is the x component? What is the y component? Well, let theta be the angle made with the positive x-axis. Okay, and so this is called the direction angle. Then the ux, you see, the ux, this is like the x. And if you can remember polar coordinates, yeah, like this is like polar coordinates. You know the r, you know the theta, and then your x is gonna be r cosine theta, and then your y is gonna be r sine theta. Do you remember that? So here is very similar. So ux is gonna be the magnitude of u, which is like the r, and then times cosine theta. Uy is gonna be the magnitude of u times the sine theta. And how about tangent theta? Well, tangent theta is y over x. So sine theta over cosine theta. So in the case here, let's say u is AB, then tangent, we're using the B over the A. Okay. Therefore, what's the angle theta? Angle theta equals, so we have tangent theta equals B over A. But then the arctangent, it depends on which quadrant the vector is located. So if u is in quadrant 1, then theta is just arctangent of B over A. If u is in quadrant 2 or quadrant 3, then we need to add pi to it, because the arctangents only cover from minus pi over 2 to pi over 2. That's quadrant 1 and 4. Okay, but sometimes some textbooks want to have the theta to be positive. Therefore, in quadrant 4, they add the 2 pi. Okay, because when you do the arctangent, in quadrant 4, it corresponds to minus pi over 2 to 0. But if you want the angle to be positive, you can add 2 pi to it to make it positive. Okay, so practice. Find the direction angle of the following vectors. Okay, So here we have 3, -4. So x is 3, y is -4, which is right here. We want to find the direction angle, theta. So now you know tangent theta, you use the y over the x. Y is -4, x is 3, right, everybody? And this is quadrant 4. So this is quadrant 4. Then your theta is approximately equals to, if the problem doesn't require the theta must be positive, then you can just do arctangent. Okay, you can just do arctangent for quadrant 1 and 4. You don't have to add the 2 pi. Just some textbook, they want you to have the theta be positive, then you add the 2 pi. But here, because the problem doesn't say so, then we don't need to do it. Arctangent. Then you plug into your calculator. You get, this is negative 53.15 degrees. Okay, everybody? So that is part A. So part B, similar. -2 and 3, right here. So tangent theta, y over x. But in this case, what is your y? Your y is 3, and your x is -2, exactly. But this is the quadrant 2, right? Quadrant 2, then your theta will be pi plus, oh, by the way, if you're using degree mode, what's pi? 180. So we use 180 plus the arctangent of -3/2. Okay? And then when you plug in your calculator, you get 123.69 degrees. So far, so good, everybody? Okay, so this is how to find the direction angle. And then applications. So find the component form of the vector that represent the velocity of an airplane descending at a speed of 150 miles per hour at an angle of 20 degrees below the horizontal. Okay, so here, and we have the vector that represents the velocity at an airplane descending. So this is the airplane, okay, and descending at an angle of 20 degrees and with a speed 150 miles per hour. Okay, so therefore we want to use a vector to denote that. So what's this vector? Okay, so this is the vector, let's say V. We know the magnitude of V is 150. And then the angle, you can see the angle is 20 degrees, but because it's moving clockwise, so you should put the theta is -20 degrees because this is clockwise. Positive theta will rotate counterclockwise. Okay, so therefore our component form, we use the magnitude of V cosine theta and the magnitude of V times sine theta. Magnitude of V 150. Cosine theta is -20 degrees. Magnitude of V 150. Sine times the angle -20 degrees. So this is what we get. Is that okay, everybody? So plug this in your calculator. And make sure you have the radian mode or degree mode. So here we're using degree. So make sure you have the degree mode. And then you get 1 40.95 and negative 95 and negative 51.30. So this is what you get after you plug in your calculator. So far, so good, everybody? Okay, and number 2. So I don't know how much time we left. So I will let you to do it as an exercise. Okay? The solution is posted on the notes with answers on our course websites. But I want to make sure we cover the remaining topics. Okay, dot products. So we do addition of 2 vectors and also subtraction of 2 vectors and scalar multiple of a vector. Okay, a scalar and a vector. Now let's do the dot product of 2 vectors. So the dot product of 2 vectors, what we do is we use the first entry, multiply them, and then add the second entry, multiply them. And the dot products, so you put a dot here. Okay, the dot products give us a number, not a vector. Okay. So here are some properties of dot products. Dot products is commutative, so you can switch the order, it does not matter. And when we multiply by a 0 vector, we just get 0. See, dot product is a number, so this is number 0. And then dot product is distributive, so we can distribute the dot products. And you also realize that v dot v, okay, so v dot v, let's say v1, v2, dot 1, v2. Okay, we're doing first component, multiply them, plus second component, multiply them. This is exactly v1 squared plus v2 squared. So, which is the magnitude of v squared. Therefore, v dot v is the magnitude of v squared. And also, scalar times the dot product is associative. Okay, you can move the c with the first vector or with the second vector. Does not matter. For example, look at the following. Let's see. So, first one, let's do 2 steps. What's u dot v? U is minus 1, 3. V is 2, comma, negative 4. So dot products, use minus 1 times 2 and plus use 3 times negative 4. Is that okay, everybody? First entry times first entry plus second entry times second entry. So we get negative 2 and 3 times negative 4 is negative 12. We get negative 14. Right, everybody? So far, so good? And then, oh, okay. So notice that u dot v gives us a number, which is negative 14. And we use it to multiply by w. W, what's w? 1, comma, negative 2. So 1, comma, negative 2. So we use negative 14 multiplied by 1. It's negative 14. Negative 14 times negative 2 is 28. Right. So we get a vector. So that product gives us a number. But when we multiply a vector, we get a vector. Is that okay, everybody? Okay. How about u? What's u times 2v? Can I move the 2 in front? Then I have u 2 times u dot v. The reason why I'm doing that because I already calculate u dot v in my part A. So I don't want to calculate again. I can use that. U dot v is negative 14. So 2 times negative 14 is negative 28. Is that okay, everybody? Yes? Mm-hmm. So, yeah, you can move the 2 in front, and then you can use the answer you get from part A. Okay, so this is problem 1. Okay, geometric interpretation of the dot products. So if we have U here and V here, let theta be the angle between U and V. Then the dot product is the magnitude of U and the magnitude of V times cosine theta. This is like the work done in physics. So you have a force F, and then you have the displacement. Okay, displacement vector. Let's say D, and then your work done is F dot D. Have you heard the work done in physics before? Yes or no? Work done in physics? You have force adding on an object and walk some displacements. Okay, never mind. You will learn it later. Okay, so this is the formula. Okay, therefore, how do we find the angle between two vectors? We can both sides divided by magnitude of U and magnitude of V. Then we get cosine theta is U dot V over the magnitude of U and the magnitude of V. Therefore, theta, we do the arc cosine of this number. We get the theta. So this is the formula. We get an angle between them. For example, here, so we first compute U dot V. So minus 1, 3, dot product, 2, 1. First entry multiply. So minus 1 times 2. And then plus second entry multiply. 3 times 1. Oh, do you see we have negative 2 plus 3, which is 1? Yes, everybody? And according to this formula, now we compute the magnitude of U. The magnitude of U is square root of each component square. Add them up. 1 plus, yeah, so minus 1 squared is 1. 3 squared is 9. So we have square root of 10, right? And then magnitude of V, square root of 2 squared plus 1 squared. What's 2 squared? 4 plus 1. Do you see we get square root of 5? Yes. Then plug in this formula. So cosine theta. Cosine theta is U dot V, which is 1, over the magnitude of U, which is square root of 10, times the magnitude of V, which is square root of 5. Yes, everybody? So you get, this is the same as, square root of 10 is actually square root of 5 times square root of 2. Yes, so that's why square root of 5 times square root of 5 give us 5. So this is like 1 over 5 square root of 2. Okay, theta is then a cosine of this number. And you plug into your calculator, you get 81.87 degrees. So this is the angle between those two vectors U and V. So this is the angle between them. Okay, everybody? In the exam, the formula will be given. Okay, so the angle between two vectors. Okay, so far so good, everybody? Yes? Some of you are not taking notes. Okay. So this is a summary of angles between two vectors. If the angle is pi, so UV angle is pi, then cosine theta will be -1. Cosine pi is -1. Okay? And we could have a obtuse angle. So this is obtuse angle. Right angle, like this. Acute angle, like this. Or U and V, they're of the same direction. So the theta is 0. Is that okay, everybody? So this is the angle between the two vectors. And notice that if the angle is 90 degrees, cosine theta is 0. Therefore, the dot product is 0. So two vectors are orthogonal even only if the dot product is 0. Okay? They form a right triangle. And 0 vector is orthogonal to every vector because the dot product of a 0 vector and any vector is 0. Okay. And then how about these two? So are they orthogonal? Well, we just check the dot products. So 2, -3 dot product 6, 4. 2 times 6 plus -3 times 4. What's 2 times 6? 12. 3 times 4? 12. Oh, do you see a 0? So we can say U and V, they are orthogonal. This is the notation saying that they are orthogonal or perpendicular. Okay, everybody? So that product can help us to figure out whether two vectors are orthogonal. All right, good. Vector components. Almost there. If U and V are non-zero vectors, and we can say, okay, so let's do the picture, okay? We're not doing the whole proof. Let's just do a picture. So let's say this is V, and let's say this is U. And then you can consider the component of U in the direction of V, and you can consider the component of U orthogonal to V. So then we can call this is like W2, and this is like W1. Okay. So W1 is parallel or in the direction at the V. And then W2 is orthogonal to V. And we say W1 is the projection of the vector U. See, you have this vector U. You project in the directions of V. Okay, so this is the projections of U onto V. We denote this is a projections of U onto the V. And how do we calculate? Well, this is the theta, right? And well, you can think of this guy, this W1 equals, we want to use a magnitude. Okay, magnitude. And times the directions. Times the direction. What's the magnitude? Well, here this is the U has the magnitude. This is magnitude of U. Okay? And what's the magnitude of W1? Do you see this is the adjacent side of this triangle? So this is adjacent. This is the hypotenuse. Adjacent over hypotenuse is which trig functions? Cosine, right? So then we see the magnitude of W1 over the magnitude of U. This is adjacent over the hypotenuse. That's why this is cosine theta. So the magnitude of W1 is magnitude of U times cosine theta. And how about the directions? Well, the directions in the V, we want to use a unit vector in V because we don't want to have a magnitude that is not 1. Okay, we only want to show the directions. So we want a unit vector. So the unit vector is V over the magnitude of V. Okay, so this is a unit vector in the direction of V. Okay, therefore, what you do is you can multiply by magnitude of V, and then you can divide it by the magnitude of V and the magnitude of V. So what I'm doing here, so I moved the magnitude of V down there, but I also multiply magnitude of V on the numerator, and below they are here. Oops. Okay. And now the numerator is actually the dot product. The dot product, u dot v is magnitude of u times magnitude of v times cosine theta. So this is u dot v over the magnitude of v squared times v. So this is the projection of u onto v. And then the orthogonal projections, you can use u minus w2 because u equals w1 plus w2. Once you get w1, then you can get w2 by doing u minus w1. Is that okay, everybody? So this formula will be given on the final exam. Okay, let's do this example. So you find the projection of u onto v, and then write u as the sum of the two orthogonal vectors. Okay, one of them is the projections. Okay, so this is a formula. First, we figure out what is u dot v. So 3 negative 5 dot 6 2. 6 times 3, yeah, 3 times 6 plus negative 5 times 2. What's 3 times 6? That is 18, right? Negative 5 times 2? Negative 10. Do you see we get 8? Yes. So that's u dot v. And then we need the magnitude of v. Do we need the magnitude of u? No. We only need the magnitude of v. So the square root of 6 squared plus 2 squared. What's 6 squared? 36. 2 squared? 4. Oh, you see square root of 40. Right, everybody? Okay, therefore, the W1, the projections of u onto v is then plug in the formula. U dot v, 8. U dot v is 8. Magnitude of v squared. What's square root of 40 squared? 40. Yes, everybody? And then times u v. Yes, see? Times v. V is 6, comma 2. By the way, you know 8 and 40, they cancel. We get 5 in the denominator. Yes, everybody? So therefore, this is 6 over 5, comma 2 over 5. So this is the projections of u onto v. Okay. And the orthogonal component, we're using u minus the w1. U is 3, negative 5. Subtract this vector 6 fifths and 2 fifths. Okay, let's see. The first components, we have 3 times 6 fifths. But you know 3 is 15 fifths minus 6 fifths. Yes? And then second component, minus 5. 5 is like 25 over 5. Subtract 2 fifths. Yeah, we're taking the common denominator. What's 15 minus 6? 9. So 9/5. Negative 25 minus 2. We get negative 27 over 5. So this is how we find the projections and the normal components of the vector u. And in this exam, the formula of the projections will be given. So problem 5, I will let you to read at home. Okay, so this is applications, and the solution is on the website. Okay, now let's do the class picture. So let's see how it works. Okay, so let's have students sit here. Okay, let's move some chairs. So we have students sit here and some students stand. Okay, so one line is sitting here, and then the other line is stand here. Yeah, let's move. Let's take a class picture. Okay. So time 10 seconds. Okay. So yeah, so just sit here. Let me move your chair closer. Just save me one spot. Do you want to one of you sit here? Yeah, sit down. Okay. So one line sit here, and then how about the back line? You can stand on the chair or table. Yes. Syria, do you want to sit in front? Okay, we have one spot here. Let's see. Nathan, stand on the chair. I cannot see you. Also, Luke, stand on the chair. I cannot see you. And sorry. Okay. Tristan, stand on the chair. Okay, do I have stack? Okay. Any parents stand on the table or chair? Okay. Let's see. Do I have everybody? Hey, this is okay. Behind, do you want to stand on the chair? Yeah, that would be great. Okay. Let's see. Hmm. Good, awesome. So 10 seconds. Wait, smile, cheese. Let's see. Let's see. We have everybody. Open your eyes. Okay. I think it's open. So this is a picture. I will email to you. Thank you. Good luck with all your finals. If you have questions, feel free to email me, and the review session